All right. To begin with, let me just announce a minor typo error and correction to homework 4. But by the way, homework 4 is due on the 29th at 5 p.m. Isang tanong lang naman to, but I think I committed a typo here last time. Binigay ko yung recursion formula. Walang nabago dyan. So ito yung kailangan nating i-correct. So the recursion formula should be true for all n greater than or equal to 1. Binigay ko naman si a sub 1. So ibig sabihin itong formula na to mag-work kapag si n ay equal kay 1. So that means when n equals 1, you will get a sub 2 using the value of a sub 1. So that's perfectly fine. And then to get a sub 3, we take n equals 2. So to solve for a sub 3, you will need a sub 2 over 2 plus 3 over a sub 2, and so on. So that's how you get the first few terms of the sequence, and then you need to prove that it is convergent. Hint, sinabi dito, ipakita na siya convergent. I don't care if you can find the limit or not. So just tell me or just convince me that the limit of the sequence must exist. Kahit hindi nyo alam yung sequence yung limit ng sequence, it's fine. As long as you can guarantee that the limit will exist. All right? And then sayang yung 1 point, sagutan niyo yung bonus question. So total is 5 over 5. Tinanggal ko na yung over. Pero siguro next time balik ko na 6 over 5. But for now, it's 5 over 5. So, then let me see. Okay. And then another reminder, the second problem set would be live on Canvas starting October 26, 8 a.m. And then it will be due on November 1, right before midnight. Parang may pa-countdown. Pagka tapos nyo magpasa ng problem set 2, then officially you are on the reading break. So yeah, medyo nag-overlap in deadline ng homework 4 and problem set 2, but I hope you don't mind. If you want, you can finish homework 4 early or earlier than October 26 and submit it in Canvas, perfectly fine. So that ang isipin nyo na lang ay problem set 2. Again, I'm thinking of, again, I'll upload 5 problems in Canvas and then you'll need to only submit 4. Pero lalagyan ko ng, konting twist yung problem set 2. Merong isang problem na required sagutan. And then you will choose 3 out of the remaining 4 to complete the 4 problems that you will submit. So may isang required na sagutan, tapos pipili kayo ng 3 dun sa natitirang 4 para yun yung isa-submit nyo. Alright? Interestingly, dun sa problem set 1, pinakamaraming nagsagot ng problem number 3. Ano nga ba yung problem number 3 doon? Yun nga ba yung i-prove na merong cube root ng o real number yung cube root ng last 3 digits ng inyong student number? Tama nga ba? Yun. Medyo na-surprise lang ako na doon pa pinakamaraming may nagsagot. Teka. Double check ko nga. Tama nga ba? Yung sumasagot sa chat eh. So, problem 3. Hindi pala. Yung problem 3 pala yung supremum. Alright. So, yung pala yung may pinakamaraming nagsagot. Which is, well, a little bit surprising for me kasi in-expect ko na ang pinakamaraming magsasagot ay sa problem 5. Okay. So, but anyway, most of those who answered problem 5 got it right. So, okay pa rin naman. Yun lang pala sa problem number 4. Gusto niyo pa ba yung may mga ganitong problem? Yung give an example without providing a proof? Kasi kung mapapansin nyo, medyo double-edged sword ito. Kasi kung tama kayo, then you get perfect score. Easy peasy. Wala akong hinahanap na reason. So, wala kayong masyadong kailangang isulat. Pero ang problema, pag mali na bigay ng example, hindi ko kayo mabibigyan ng partial points. Kasi titingnan ko lang, tama ba yung example yung nabigay or hindi. So, dun lang siya nakadepende. So, parang naging all or nothing per problem or per item yung problem number 4. So, yung iba dun nadali sa all or nothing. Kasi kung may proof, so mabibigyan ko kayo ng partial credits. Pero dahil walang proof na required o walang explanation na required, then yun yung naging problema. So what do you think, guys? Gusto niyo pa ba ng ganun or wag na lang? Medyo madali sa akin yon pag ako yung mag-check kasi kakunti yung babasahin ko. Meron ako na-encounter na 2 or 3 submissions na pinag-isipan ko talaga kasi hindi ako sure kung tama ba yung example. So kaya naglagay ako din ng comment. Pag hindi ako sure, hindi ko na-justify sa sarili ko na tama yung example nyo, parang ziniro ko. So pero kung meron kayong explanation, nilagay ko doon kung ano yung tanong ko. Kung may comment ako na, totoo ba ito? So kung ma-justify nyo sa akin, then pwede ko kong ibigay sa inyo yung points na tinanggal ko. Pero anyway, yeah. Sabi ni Ned, basta hindi po sobrang hirap ng problem. Okay, yeah. I'll try to do that. Pero yeah. Based on the results of the problem set, of the first problem set, mukhang hindi naman ganun kahirap. Tama ba? Or talagang produkto siya ng dugot pawis, no? Kasi actually, I'm quite impressed with your answers to the problem set, your performance in general. Kasi nga sabi nila yung 155 isa sa mga pinakamahirap na courses. And yet, the results of problem set 1 and also of your homeworks are stellar. Maganda yung performance mo. So, hindi ko alam kung napadali yung problem set 1 or magagaling lang talaga kayo. So, yeah. So, let's see sa problem set 2. Sana ma-maintain nyo yung level. Sana hindi nyo inisip na si Sir naman masyado kaming minamaliit. Napakadali ng mga tanong sa problem set 1. So, sabihan nyo lang ako kung gano'n. Pwede kong taasan yung level sa problem set 2. Alright, so I'll just wait for your, kung ayaw nyo mag-comment live, I'll just wait for your answers dun sa homework 4, problem 2, kasi nagpa-comment ako dun sa problem set. So I'll just read on that later. And now let's go back to the module. Definitely we'll finish it today. Kasi yung coverage ng problem set ay hanggang dito sa unit 2, ay unit 2 lamang. So yung mga problems dito manggagaling. But in answering the problems in the coming problem set, you might need some concepts from unit 1. Ganun naman sa math eh. Ang math kasi sequential. Hindi nyo pwedeng kalimutan yung mga natutunan nyo before. So kasi posibleng magamit nyo sila or kailanganin natin sila yun sa mga current topics. Like the completeness actions. We keep on blabbering about the completeness action kahit nasa chapter 1 siya or unit 1 siya. And yet, nag-play siya ng vital role dito sa problem set 2, dito sa unit 2. And that might also be the case in the problem set. Okay? So with that in mind, let's take a look at this section, the last section for the unit, compact sets. Meron lang 4 na bullet dito, kaya malakas yung loob ko na tagalan yung pakikipagkwentuhan or pag-attempt na makipagkwentuhan sa inyo. Because there are just 4 bullets here. 2 theorems, 1 definition, and 1 example. And the first of which is Theorem 13. So Theorem 13 is just a characterization of limit points. Okay? Late to na-introduce kasi gagamitin ko siya mamaya dun sa proof ng Heine-Borel theorem. But essentially, we say that a point X is a limit point of a set A if and only if there exists a sequence contained in A that converges to X. Kaya pala siya tinawag na limit point. Sabi ko nga dati, yung pagkakapangalan ng mga terms sa math, laging may backstory yan, or most of them has or have a backstory. So bakit siya tinawag na limit point? Limit point siya ng isang set A kapag meron or if and only if. So characterization to. Pwedeng ito yung definition natin ng, pwedeng ito yung kunin nating definition ng limit point. So characterization of limit points, aside from the definition, the very definition that we gave earlier, limit point siya if and only if makakahanap ka ng sequence dun sa set A na nagko-converge kay X. So ang collection ng limit points, sila lang yung mga limits ng mga sequences na contain kay A. So kunin mo lang lahat ng posibleng sequences kay set A. And there would be infinitely many of them, right? So lahat ng limits ng mga sequences or lahat ng maging posibleng limit ng isang sequence, sila yung mga limit points ni set A. Okay? And then let's try to prove it. Kahit sabi dito ay exercise, pero we have lots of time today, so probably let's try to prove it. Right? Nandito siya sa exercises. All right, so I hope you remember how to prove biconditional statements kasi nga if and only if to. So we can think of it as a two-way theorem or two theorems lumped together. So una, i-assume natin na limit point siya kasi pakita natin na limit siya ng isang sequence na contained kay A. May requirement pala dun sa sequence containing A. Dapat hindi lahat, hindi lang pala hindi lahat. Lahat ng terms dun sa sequence ay hindi equal kay X. So limit point siya kapag ka merong sequence na walang term na equal sa kanya na nagko-converge kay X. Right? So, and then the second part of this theorem is to show that if X is a limit of some sequence contained in A that doesn't contain X as a term, then X is a limit point. So dalawa yung ipoprove natin dito. So let's start the proof and let's do the forward problem first. So here I'm gonna assume that X is a limit point of A, right? So limit point siya nasa derived set siya, right? Then we want to show that there exists a sequence contained in big A, such that an is not equal to X for all n, and limit of an as n approaches infinity is equal to X. All right, so ito yung gusto natin ipakita using the assumption that X is a limit point. All right, so ano ba yung pwede natin makuha mula sa pagiging limit point? Can anyone remind me what does it take for X to be a limit point by the previous from the previous things that we learned? Just raise your hand if you want to answer. Sayang bonuses sa problem sets. By the way, dun sa top notchers kanina, hindi pa kasama yung bonuses. So, hindi ko pa siya natatali. Siguro, pag sinipag ako mamayang gabi, i-encode ko kay Canvas kung ilan yung bonus nyo due to recitation. So, anyone who wants to grab the chance? Ano yung pwedeng next step ko dun sa proof? Ang alam ko lang, limit point si X. So, ano yung pwede kong masabi kung limit point si X base sa mga previous discussions natin? Pwedeng layman, pwedeng taglish, pwedeng mathematical. So, bahala kayo. So, hindi ka lang technical yung answer. Pwedeng ikwento nyo lang sa akin, then I'll take it from there. Sige na guys. Bawal mahiya. Ayaw? Alright, so kung ayaw nyo, ayan, sige, Carlo. Pwede ka mag-unmute, Carlo?
Okay, sorry. X is a limit point if there exists a Y that's an element of the E neighborhood of X na nag-intersect sa set A where X is not equal to Y.
All right, so thank you, Carlo. That's right. So dahil si X ay limit point, then we know that, so i-box ko lang to para alam nyo na hindi to part ng proof. Ito yung gusto natin ipakita. Okay. Now, since X is known to be a limit point, then for all epsilon greater than 0, there exists a Y different from X, such that Y is an element of the intersection of the epsilon neighborhood of X and the set A. All right? And then, dito ko dapat makuha yung pagiging limit niya ng isang sequence. So, what we want to show is the existence of a sequence. So, one way to attack this problem ay mag-construct ako ng sequence na nagko-converge kay X. Satisfying na si AN ay hindi equal kay X sa lahat ng N at saka si AN ay subset ni A. Right? And then, huhugutin ko siya mula dito. Now, I need to employ a certain trick here para ma-construct ano ba yung sequence na pwede kong gamitin. And so for any natural number n, okay? So kasi kailangan kong mag-construct ng A sub n. So kailangan kong ibigay ano yung itsura ng mga elements ng sequence sa A sub n. But I'll first note that for any n in n, any little n in the set of natural numbers, then there exists an A sub n in A, right? Such that, actually, wag munang n, sabihan muna natin siya ay real number, such that A sub n is an element of the epsilon neighborhood of x with radius 1 over n, or the 1 over n neighborhood of x intersection the set A, such that, or with A sub n not being equal to x. Alright? So dahil sabi ni Carlo, pumili ako ng kahit anong epsilon, non-empty yung intersection ng epsilon neighborhood ni x at saka ni A, tapos yung intersection nila ay hindi equal kay x. So dahil totoo to sa lahat ng epsilon, pwede kong piliin si epsilon to be equal to 1 over n for any natural number little n. Alright? So ibig sabihin, pag pinarticularize ko yung definition na to kay 1 over n, so yung intersection ng 1 over n neighborhood ni x at saka ni A ay non-empty. It will have a member aside from x, and I'll call that A sub n. Okay? Yung pagpili ko ng A sub n ay specific sa isang n. Tapos kahit ipili lang ako ng isang element ng intersection, kahit sinong element nitong intersection, basta hindi siya equal kay x, siya yung tatawagin kong A sub n. And I can do this for any natural number n, right? And then we will come up with a sequence. Then the sequence A sub n is a subset of A. Dahil lahat ng terms kay A sub n ay kinukuha ko sa intersection. So it follows na yung mga A sub n's ay na kay capital A. And that makes the sequence A sub n a subset of A, and all of the A sub n's are not equal to x. Okay? So almost there na ako. Meron na akong candidate sequence. Ano yung kailangan ko sa sequence na to? Dapat itong sequence na to mag-converge kay x. And then we're done with the first half of the proof. All right? Making sense so far? Gumagalaw ba yung screen ko sa inyo? Or nag-freeze din ba siya? Nag-freeze kasi siya sa laptop ko eh. Nakita niyo naman nagsusulat ako?
Yes po, sir.
Okay, thank you. Bagal lang siguro yung internet ko sa laptop. Okay, then now what we want to show, yung natitira, limit dapat ni an as n approaches infinity ay equal kay x. And then after this, we're done. Now, what do we want to say? So here, let's say given any epsilon greater than 0, okay, we need to find a capital N, right? So we choose capital N to be a natural number such that what? I think we can choose capital N so that 1 over n is less than epsilon, the existence of which is guaranteed by the Archimedean principle. Okay? So pag binigyan ako ng epsilon greater than 0, piliin ko si capital N such that si 1 over capital N ay mas maliit kay epsilon. So I can choose n large enough so that 1 over n is less than epsilon. Okay? Then, for any little n greater than or equal to capital N, then we have the following inequality. Okay. So yung A sub n ay magiging member ng B sub 1 over n. Hold on. Tingnan natin kung tama to. So, totoo ba na si A sub n ay element ng intersection ng 1 over n neighborhood ni X at saka ni A? Yes, this is by the construction na ginawa natin kanina. And then what can I say about this? When this says that the distance between X and A sub n is less than 1 over n. All right? So this means the distance between A sub n and X is less than 1 over little n. Okay? But little n is greater than capital N. So that means 1 over little n would be smaller than 1 over big N. Okay? Coming from this assumption, right? But 1 over n, or n was chosen so that 1 over capital N will be less than epsilon. So in summary, we have shown that for sufficiently large n, pag malalaki na yung little n, yung distance mula kay x, yung a sub little n, ay lagi nang mas maliit sa epsilon, however small that epsilon is. Okay? And then therefore, that proves that the sequence a sub n converges to x. And then we are done with the first part of the proof. Right? Napakita na natin na kung limit point siya, may isang sequence na nagko-converge kay x na properly contained kay A, na yung mga ANs ay lahat hindi equal kay x. Or lahat ng AN ay hindi equal kay x. Right? Now we need to prove the converse. So conversely, usually nga pala sinisimulan ko yung part ng biconditional by writing the direction that I want to prove para mas clear lang sa akin. So here we'll prove the converse. So we will assume that there exists a sequence which is contained in A with A sub n not equal to x for all n, and A sub n converges to x. And then from here, we want to show that x is a limit point of A. Yung pabaliktad naman ang ating ipoprove, right? And again, as in any proof, we can start by looking at what does this mean. Ano yung ibig sabihin ng pagkakaroon ng pagkakaroon ng sequence na nagko-converge kay x, right? Can anybody remind me again? Ano yung pwede kong kunin mula sa assumption natin? Anyone aside from Carlo? Ano kaya yung pwede kong isunod dun sa proof? Clue? Isa lang naman yung assumption ko. Merong sequence. Tawagin nating AN na nagko-converge kay X. Ano yung pwede kong sabihan mula doon? Ano yung pwede kong mahita dun sa assumption na lang? Exhausted na ba talaga kayo at ayaw nyo nang sumagot? Oh yes, Ned. Any suggestion?
Try lang po, sir. Ano po, may nag-exist po na point such that may parang nandun siya sa open neighborhood ni X. Ay, sa epsilon neighborhood ni X.
Aha. Yes, yun yung eventually gusto kong mapuntahan, right? Para maging limit point siya. Pero ano siguro yung step, yung first step? Bago ako makarating doon, ano yung kailangan kong daanan? And then all I can use is this assumption. So eventually gusto kong pakita na merong element yung intersection ng epsilon neighborhood ni X at saka si A. Alright? Now, paano ko kaya siya mapapakita? Any other ideas? Pero on the right track yung kay Ned. Kaya lang masyadong advanced. Advanced yung, yung pag-iisip niya. So, bago ako makarating doon, ano yung dadaanan ko muna? Come on, guys. Pambawi dun sa mga minus 0.1, 0.05, mga minus ko dun sa problem sets niyo. Kung hindi kayo makapag-open ng microphone, just raise your hand and then mag-type kayo dun sa chat box. So baka kasi, kaya pala hindi kayo nagsasagot, wala kayong microphone. Okay? So kung walang hahabol, then the idea here is apply the definition. Tapos mula din sa definition ng pagiging convergent ng sequence kay X, doon kuhugutin yung sinuggest ni Net. Doon kukunin yung pagpapakita na yung intersection ng epsilon neighborhood at saka ni A ay non-empty. Right? So then we know that for any epsilon greater than 0, okay, there exists a capital N in N such that whenever little n is greater than or equal to capital N, then the absolute value of an minus x is less than epsilon. All right, ito yung sinasabi ng theorem. Right? Ito yung sinasabi ng definition ng pagiging convergent ng sequence. All right? And the idea here is this means that si A sub n ay laman siya ng epsilon neighborhood ni X. Tama ba? Kasi nga yung layo ni A sub n mula kay X ay mas maliit sa epsilon. So dapat si A sub n nagbe-belong dun sa epsilon neighborhood centered at X. Tapos alam natin na si A sub n o yung sequence ng mga A sub n's ay subset ni A. So ibig sabihin ito ay na kay A. Tapos hindi pa pala doon natatapos kasi lahat ng A sub n ay hindi equal kay X. So therefore, this epsilon neighborhood has an element other than X. Sabi nga natin, laman niya si A sub n. Kahit ano pa yung epsilon, merong term nung sequence na ang layo mula kay X ay mas maliit kaysa kay epsilon. Kasi alam natin na lahat ng A sub n ay hindi equal kay X. So ibig sabihin, si A sub n ay different from X, which satisfies the requirement ng definition ng pagiging limit point. So this implies X is a limit point of A. And that completes the proof. So the essence of Theorem 13, it gives us a necessary and sufficient condition for a limit point. So if you are if you're thinking about sequences, kung binigyan ka ng limit point, pwedeng hindi ka na dumaan sa epsilon neighborhood definition ng limit point. Pwedeng isipin mo na lang, limit point siya. Kaya siya tinawag na limit point, merong sequence na ang limit ay siya. Alright? Kaya ganun yung pagkakapangalan dito. So I guess it's easier to remember the definition of a limit point if you'll be thinking in the context of Theorem 13. Kaya previously, before coming up with this, before discussing sequences, I want to call a limit point as a accumulation point. Kasi parang mas apt siya dun sa definition na kahit gaano kaliit yung epsilon neighborhood, laging may element yung set na nandun sa epsilon neighborhood na yan. So parang nagkukumpulan yung mga elements ng set doon sa accumulation point. And then itong limit point siya kasi limit siya ng isang sequence. So kaya lang in Theorem 13, pinakita niya na equivalent pala yung dalawa. So a limit point is the same as an accumulation point and vice versa. And you can interpret that depending on the context, kung ano yung gusto nyong i-prove. Okay? So, all right, so that completes the proof. So one bullet down. And then second bullet, definition 9. So definition 9, dinidefine niya kung ano yung isang compact set. A set K is said to be compact if and only if every sequence in K has a subsequence that converges to a limit that is also in K. Right? So idea rito ay compact siya kapag kahit anong sequence na nandoon sa loob ni K ay merong convergent subsequence na nagko-converge sa isang element ng set na yon. Medyo mahirap i-imagine yung pagiging compact kasi dapat daw lahat ng sequence sa kanya hindi kailangan mag-converge pero dapat merong convergent subsequence. So parang napaka-generic ng requirements ng pagiging compact. And just to warn you, maraming alternative definitions sa pagiging compact. So kapag halimbawa nagpa-problem set ako tapos may tanong about compact sets, pag nag-search kayo ng other references o nag-search kayo ng inspiration para dun sa proof, be careful kasi baka iba yung definition nila ng compactness. So baka isang equivalent form ng definition 2.9 yung ginamit niya. So hindi niyo yun pwedeng gamitin sa proof ng isang statement na ibibigay ko. Kasi ang definition ko ng compact set ay lahat ng sequence contained in K ay may subsequence na nagko-converge sa isang element ni K. Right? Though later we will meet the Heine-Borel theorem, which gives us an equivalent definition or characterization of compact sets. Okay? Yeah, for now, all I can offer you is example 2.7. Ito yung madaling example ng compact set. Now, in example 2.7, it says that isang example, ang classic example ng mga compact sets ay mga closed intervals. So mga closed intervals ay compact. Bakit siya compact? Dapat na-satisfy niya yung condition ng definition, right? So pag kumuha ka daw, sabi ng definition, pag kumuha ka ng sequence na subset niya, dapat merong convergent subsequence. All right? So if we have a sequence that is inside the closed interval, then we are sure that the elements of A sub n are bounded below by C and bounded above by D, right? Kasi nandun nga lahat ng terms doon sa closed interval AB. So in essence, the sequence A sub n is bounded. And then thanks to the Bolzano-Weierstrass theorem, kasi parang yun pa lang yung major theorem natin that talks about subsequences, right? Eh, ang kailangan natin sa compactness ay pagkakaroon ng convergent subsequence, right? So parang yun yung clue na si Bolzano-Weierstrass lang yung pwede ko magamit. Right? So by the Bolzano-Weierstrass theorem, which recall, ang sinasabi niya ay every bounded sequence has a convergent subsequence. Right? So dahil bounded yung sequence, by the Bolzano-Weierstrass theorem, meron siyang convergent subsequence. Alright? So yung kalahati ng condition ng pagiging compact ay nasatisfy na. Meron na tayong subsequence na nagko-converge. Pero meron pang isang requirement yung definition. Dapat yung limit ay nakay set K din. So kapag meron kang sequence sa loob ng closed interval, sure tayo by Bolzano na meron siyang convergent subsequence. Kailangan nating ipakita na yung subsequence na yon ay nandun sa closed interval CD. Okay? But that's not too hard to imagine kasi ano ba ang alam natin sa closed intervals? Ang closed intervals, ang classic examples ng closed sets, right? We remarked earlier that any closed set is closed. Any closed interval is closed. Kaya nga maraming tumama dun sa problem 4 sa problem set kasi nga madaling mag-isip ng mga closed sets, all right? So, ibig sabihin, kung closed siya, ibig sabihin nako-contain niya lahat ng limit points niya. So, yung limit point ni A sub n ay dapat nandoon sa closed interval CD. Kasi nga, closed ang closed interval. Isang closed set ang isang closed interval. And so, both requirements of being compact is satisfied. So, therefore, we can conclude that a closed interval is compact. At sila usually yung building block ng pagkakaroon ng compact sets. Kasi nga parang ang hirap talagang i-imagine ng pagiging compact kasi kailangan ng convergent subsequence na nagko-converge sa kanya. Right? But I hope that gives you a little bit of an idea what a compact set is. Right? Pero don't worry kung mahirap siyang imagine kasi mahirap naman siya talaga. Alright? Now, to make it simpler, we need to look at the Heine-Borel theorem. Thanks to the mathematicians Heine and Borel, kalimutan ko yung mga first names nila. Na-search ko na kanina eh. Pero anyway, these two mathematicians or these two guys made our lives easier by giving us a nice criterion, a nice characterization of compact sets. Sabi nila, pwede mo nang itapon yung definition ng compact set na yan. Kasi thanks to the completeness axiom, dito sa axiomatic system natin, pwede nating sabihin na lahat ng compact set ay closed and bounded, and vice versa. So meaning, kapag yung set mo ay closed at saka bounded, automatically siya ay compact. And the converse is also true. Kung compact siya, dapat siya ay closed and bounded. So pag pinaghanap ko kayo ng example ng isang compact set, kung sedista kayo, sige, pahirapan niyo yung sarili niyo, tingnan niyo yung definition 2.9, isa-isahin niyo lahat ng sequence na nandun sa set na yon, tapos dapat meron siyang convergent subsequence sa isang element ng set. But you can use the Heine-Borel theorem to argue na ang kailangan ko lang ipakita na para ma-prove na compact yung set ko, siya ay closed at saka bounded. Hindi ganon kahirap ipakita ng isang set ay closed at saka bounded, right? Nadaanan natin yan with the previous exercises, right? So there's only one thing left to be done. Kailangan nating i-convince yung mga sarili natin na totoo yung Heine-Borel theorem. Okay. Now let's try to prove it. Kasi marami naman time. Sana ipapa-reading assignment ko yung proof ng Heine-Borel. Pero sige, try natin. Kung maggagawa kayo, if you will do a quick search in Google or in your web browsers, or actually even in other textbooks, pag sinearch nyo yung Heine-Borel theorem, iba't ibang klase ng proof yung makikita nyo. Kasi depende dun sa development ng real analysis o ng advanced calculus na ginamit nila. For example, in the other book that I am using, aside from Abbott, ang definition niya ng compact set niya ay meron siyang finite subcover. Kaya lang ang problema, hindi ko magamit yung proof mula dun sa isang book na ginagamit ko kasi hindi naman natin define ano yung isang covering ng isang set. Alright? So, kaya yung iba gumagamit ng G-delta sets, yung iba, ano pa nga ba ginagamit nila? Yung iba ginagamit nilang definition ng closed and bound, ng compact ay closed and bounded. So, iba yung version nila ng Heine-Borel. So, depende talaga dun sa pagkaka-develop sa mga books or websites na i-visit mo. So, be careful when reading proofs, especially about compactness. Kasi nga, kung papansin niyo yung definition 9, medyo mahirap siyang i-visualize. That's why some texts avoid this definition. Definition nilang pinipili ay finite subcover, lalo na sa topology kasi mas madali siyang i-picture. Pero for us, to make use of this development, nag-stick tayo sa Theorem 2.9, sa definition 2.9. And with that, yung Heine-Borel theorem natin will provide us an easier characterization of compact sets. Kailangan lang pala siya ay closed and bounded. But again, this is a characterization, alternative definition, so it must be a biconditional statement. And it requires a twofold proof. Dalawa yung kailangan natin i-prove. Una, compact siya implies closed and bounded, and also the converse. Closed and bounded siya, dapat mag-follow na compact siya. That's what we'll try to do here. So first, we'll prove the forward problem or the forward statement. So we assume that K is compact. Then we want to show W3S na lang pala. We want to show that K is closed and bounded. All right? And then, ang panggagalingan ko lang yung assumption na siya ay compact. So that means, what can I say here? Ito pala yung mas mahirap na side na yung pagpapakita na siya ay compact. Kasi yung closed and bounded implies compact parang ipapattern lang natin yung arguments mula dun sa example kanina, sa proof dun sa example kanina. Pero tingnan natin, dapat siya ay closed and bounded. All right, perhaps I can do it this way. Gusto ko ipakita na siya ay closed and bounded. Simulan ko siya sa pagpapakita na siya ay closed. Ano ang ibig sabihin ng pagiging closed? Ito yung nabanggit na nga pala natin kanina. Closed siya kapag lahat ng epsilon neighborhood ay nagko-contain ng element ng set aside from itself. Right? Or, hindi, anong sinabi ko? Closed siya kapag laman niya lahat ng limit points niya. Yan. Closed ang isang set kapag laman niya lahat ng limit points niya. So I will suppose, or I will let X be an element of K prime. Kunwari si X ay isang limit point ni K. Kasi ang gusto kong ipakita ay si X mag-belong din dapat kay K. Para masabi ko na lahat ng limit point ni K ay nagbe-belong kay K, therefore closed si K. Right? Gusto kong ipakita. Now, what do I know about limit points? I can go by the definition of being a limit point, or I can take advantage of Theorem 13. Sabi ng Theorem 13, kung limit point siya, then there exists a sequence A sub n properly contained in K such that A sub n is not equal to X for all n, and A sub n converges to A. Sorry, not A, but to X. Okay? Ito yung kaya in-introduce yung Theorem 13 kanina. And then, what can we say from here? Gusto ipakita na siya ay closed. Gusto kong makarating sa X element of K. But how can I get there? Well, dahil totoo ito, then we can treat, sige, sulat ko na yan. Then we can treat AN to be a subsequence of itself. Wait, tama ba yung phrasing nun? Balikan ko lang yung definition. Kapag lahat ng sequence ay may isang subsequence na nagko-converge kay K. Alam natin yung A sub n nagko-converge kay X. So therefore, any subsequence of AN must converge to X, right? So dahil I think we have a result last time na pag sinabi na pag convergent yung sequence mo, dapat lahat ng subsequences niya ay mag-converge kay X din. Parehas yung limit ng actual ng mother sequence at saka ng subsequence, right? So ibig sabihin, kahit na anong subsequence ni AN, dapat mag-converge kay X. Right? Do you agree with that? Tama ba, guys? Tulungan niyo naman ako, guys. Convinced naman doon? Right? Pag convergent yung sequence, dapat convergent lahat ng subsequence niya. And not only that, we have proven before na lahat ng subsequence dapat mag-converge doon sa actual limit. Kasi otherwise, pag nakakita ka ng dalawang convergent subsequences na magkaiba yung limit, then automatically by divergence criterion, siya ay divergent na yung actual sequence. Yung contrapositive niya will tell us na dapat unique yung, dapat lahat ng subsequences nagko-converge kay X. Kaya lang ano yung alam ko about X? X is a member of a compact set, right? And also, A sub n Actually, hindi ko pa alam kung si X ay element ng compact set, pero ang alam ko ay yung sequence ay subset ng compact set. But by the definition of a compact set, dapat ay lahat ng merong subsequence na nagko-converge sa isang element ni K. So, lahat ng subsequence ni A yan ay nagko-converge kay X. Pero si K ay compact. So, dapat lahat ng subsequences na nasa loob ni capital K ay mag-converge sa isang element ni K. So, from there, we can conclude that X is element of K since K is compact. Okay. So therefore, we can say that K is closed. Kasi kahit na anong limit point niya ay nasa loob niya. So it contains all of its limit points. Okay? So one down, napakita na natin na si K ay closed. So next challenge is to show that K is bounded. Paano natin mapapakita na si K ay bounded? So dapat lahat ng elements ni K ay mahanapan natin ng lower, si K dapat may lower at saka may upper bound. Ito pala yung mahirap sa proof. Mali yung iniisip ko kanina sa proof. Iniisip ko na dahil convergent yung sequence, automatically bounded yung sequence. Tama, bounded nga naman yung sequence, pero ang gusto ko nga palang ipakita, si K yung bounded. Paano kaya mapapakita na si K ay bounded? Any suggestions? Ito yung hindi ko pa napag-isipan pala. Paano ko mapapakita na bounded si K? Kaya by contradiction? Suppose ko that K is not bounded. Okay, so ang inisip ko ay, pwede ba mag-work ito? What do you think? I-assume ko na siya ay unbounded. So, in particular, wala siyang upper bound. Kung wala siyang upper bound, makakapag-construct ba ako ng sequence na divergent hindi lang pala divergent, ng sequence na unbounded na walang subsequence na magko-converge sa isang element. Yeah, what do you think, guys? Mag-work kaya? Ito pala yung pinakamahirap na part, yung pagpapakita na bounded. Any ideas? Oh, saklolo guys. Na-stuck ako. Paano ko may papakita na siya ay bounded? Sige, try natin. Sulat natin yung mga ideas. Brainstorming ba? Okay. Suppose for the sake of contradiction that K is not bounded. Okay. Then you can form an unbounded sequence AN that is properly contained in K, right? And without loss of generality, let's assume that A sub n goes to positive infinity. All right? Ito yung inisip ko. Suppose for sake of contradiction na si K ay hindi bounded. So dahil hindi siya bounded, then makakapag-form tayo ng isang unbounded sequence. Say A sub n that is properly contained in K. So halimbawa si K ito. Halimbawa ito yung set K. This is set K. Kung siya ay unbounded, kaya kong makagawa ng isang subsequence na unbounded. And not just unbounded, pero nagko-converge kay positive infinity. Right? So, ibig sabihin, pwedeng ito si A1, ito si A2, ito si A3, si A4, si A5, si A6, and so on. Dahil unbounded si K above, or I can assume that it is unbounded above, so hindi ako mauubusan ng terms pa kanan, right? So pwede akong kumuha ng mga elements habang pumupunta ako sa kanan. So I can actually create a monotonic sequence that converges to positive infinity, or that diverges to positive infinity. If, on the other hand, kung si K ay unbounded below pero bounded above, pwede ko namang kunin yung sequence na pakaliwa naman. Ito si A1, ito si A2, ito si A3, ito si A4, si A5, ito si A6. And with the supposition that K is unbounded, ibig sabihin kaya kong pumunta sa kaliwa indefinitely. So lagi akong may mahanap na sequence na nag-diverge to positive infinity or negative infinity depending on the nature of the unboundedness of the set K. Right? And then if that is the case, then there will be no subsequence A sub n K that will converge to an element of K. Isang idea, kung ang elements natin ng sequence, A1, A2, A3, A4, and so on, right, ay laging nag-i-increase indefinitely, kahit anong kunin nating subsequence niya, hindi magko-converge to an element of K. Kasi sinabi natin yung kinonstruct natin na sequence ay nagda-diverge to positive infinity. So kahit na anong subsequence ang kunin ko ni A sub n, lagi na lang yung elements niya papunta sa kanan. Alright? So ibig sabihin, palaki ng palaki yung elements ng subsequence. Kasi nga, wala tayong choice. Yung mga elements ng sequence natin laging papunta sa kanan. So pag nag-harvest ka ng mga elements to form a subsequence, lagi rin silang pakanan ng pakanan. And that will be a divergent sequence. And in particular, siya ay hindi siya magko-converge sa isang element ni K. Because at most, we can say that that subsequence will converge to positive infinity. And positive infinity is not a real number, so therefore it will not belong to K, which is assumed to be a subset of R. And then this is a contradiction. This contradicts the fact that K is compact. Kasi pagka-compact yung set, dapat lagi kang may mahahanap na subsequence na nagko-converge sa isang element ng set. And yet here, we have demonstrated the possibility of constructing a subsequence, namely a subsequence that goes indefinitely to the right or indefinitely to the left, depending on how unbounded the set K is, na hindi nagko-converge sa isang element ni K. Right? And so we must reject our original supposition that K is not bounded. So our conclusion, K must be bounded. Kasi imposible na maging unbounded siya. Okay? And that proves the sufficient condition, or that being compact is sufficient to conclude that the set is closed and bounded. Then let's now go to the other half, which is the converse. So for the converse, we would like to prove that P is necessary for Q. Na pag si Q ay totoo, dapat mag-i-imply na si P. Yung Q natin dito ay si set K ay closed and bounded. So I want to show that being closed and bounded is being compact is necessary for a set to be closed and bounded. So automatically daw, pag closed and bounded siya, dapat compact siya. Right? So i-assume ko sa converse, sa proof ng converse, na si K ay closed and bounded. So assume K is closed and bounded. And from that assumption, we want to show that K is compact. Right? Okay. So box ko lang to, hindi yan part ng proof, pero guide natin to para mapakita na siya ay compact. And fortunately for us, isa pa lamang yung alam natin na condition para masabi natin na compact yung isang set. Kailangan natin ipakita na kahit anong sequence ay may convergent to subsequence kay K. Right? So I'll start with that. So I'll suppose suppose that A sub n is a sequence in K with A sub n not equal to hindi ko pa pala kailangan yan, right? I'll just consider a sequence in K. Tapos gusto ko mapakita na itong sequence na to ay may subsequence na nagko-converge sa isang element ni K, right? Kasi yun yung definition ng pagiging compact. Now, what do we know? We know that K is bounded by our assumption. So therefore, by the Bolzano-Weierstrass theorem, dahil si K ay bounded, sabi ng Bolzano-Weierstrass, there exists a subsequence siguro sa na line na lang. There exists a subsequence A sub nk of an that is convergent. Okay? Sabi ng Bolzano-Weierstrass, kapag ka bounded yung sequence, automatic meron siyang convergent subsequence. Alright? Now, in-assume natin na si A sub n ay subset ni K. Pero si K is assumed to be bounded. So that means the sequence is bounded as well. Dahil bounded siya, sabi ni Bolzano-Weierstrass, meron siyang isang convergent subsequence. Right? That is A sub nk converges to some A element of R. Right? However, part of our assumption is that K is closed as well. Dahil si K ay closed, right? But since K is closed, ibig sabihin dapat laman niya lahat ng limit points niya, right? Siguro pre-empt ko muna to, wag muna siya. Paano ko masasabi na closed siya? So dapat laman niya lahat ng limit points niya. Pero alam natin, limit point siya kapag ka merong sequence na nagko-converge sa kanya, right? By Theorem 13. So dahil si A sub nk ay nagko-converge kay A, and A sub nk is a sequence on itself, right? So ibig sabihin, then tama ba yung logic ko? Wait. Gusto ko kasing ipakita si A ay nakay big K para masabi na compact siya. Di ba? Yung definition ng compactness requirement na yung subsequence na nagko-converge sa isang element ni big K. Ang alam ko pala ngayon ay yung subsequence ay nagko-converge sa isang real number A. So ipakita si A ay nakay K. Ano yung pwede kong gamitin na si A ay nagbe-belong kay K? So this means A is a limit point of K. Tama nga ba? Dahil nakakita tayo ng isang sequence, namely si A sub n K. Remember, ang mga subsequences ay sequences then on their own right. So, ibig sabihin, nakakita tayo ng isang sequence, si A sub n K, na nagko-converge kay A. Eh si A sub n K ay isang sequence na nasa loob ni K. So therefore, dahil merong isang sequence na nasa loob ni K na nagko-converge kay A, so dapat si A, by Theorem 13, ay isang limit point ni K. Right? Pero ano pang isa nating alam about K? We know that K is bounded. Sorry, hindi bounded. Si K ay closed. Alam ko si K ay closed. And sabi ng definition ng pagiging closed, closed siya kapag laman niya lahat ng kanyang limit points. All right? So that means A is a limit point, and so since K is closed, then that means A must be in capital K. All right? So let's review what we have right now. We have a sequence in K that has a convergent subsequence to an element of K, which satisfies the definition of compactness. So therefore, K is compact. End of proof. All right. So that proves the Heine-Borel theorem, which is a very powerful theorem because this gives us an insight on how to determine or gives us an insight about the compact sets na mahirap i-imagine kung titingin lang tayo sa definition 9. From now on, by the Heine-Borel theorem, pwede natin sabihin, compact siya kung siya ay closed and bounded and vice versa. So if I'll ask you for an example of a compact set, pwedeng magbigay lang kayo sa akin ng set na closed and bounded at the same time. Right? Because of the Heine-Borel theorem, it follows automatically that that set will be compact. Right? And I think that's the end of the unit. Right? So any questions? Sorry, medyo lagi yung proof ngayon. That pala sinulat ko siya beforehand. But again, parang mas gusto ko yung spontaneous kasi hopefully sana nakasama kayo sa thinking process. So hopefully next time, mas marami na mag-participate or makipag-brainstorm. Wala naman deductions kung mali yung hula nyo or yung idea nyo. Okay, any questions? Or any questions about the problem set? Any concerns? Wala na? Wala na kayong concerns? Okay. If there are none, then yeah, let's call it a day. Probably I'll upload the module Unit 3 lecture notes probably over the weekend. So you can just take your time and review Unit 2. Yun muna yung isipin nyo para ready kayo sa problem set next week. But by the weekend, I will also upload Unit 3 kasi sisimulan na natin yung Unit 3 on Tuesday. All right? So wala nang pahabol na concerns or questions? Kung wala na, okay, thank you guys for coming and have a good weekend. Let's see each other again on Tuesday. Bye, everyone.
Thank you.
Salamat po.
All right.
Thank you, sir.